So, math students at Alice Vale, here we go. We are going to pick up some steam and keep going with our notes, and we have notes for number sense 7, NS7 today. We're looking at opposites and absolute values of rational numbers. Rational numbers. Yes, rational numbers are decimals and fractions, plus all the positive and negative whole numbers. We just discussed this in class, so let's keep it straight. Now, what we're looking at is opposite. Okay, opposites. Absolute value. So we're talking about 0 here somewhere. So look at this. Opposite tells us it is the same distance. The same distance from our old buddy 0 on the number line. Okay, same distance from 0. So let's look at this number line. We got our 0. Remember, your teacher can't tell what anything is if you don't tell us where 0 is. We can find everything else, but you have to show us where 0 is. All right, so 0 is there, and we have 2 empty boxes. Let's see what these boxes are. We're going to count. Here's 1, 2, 3, 4. This would be the 5th box. And we went to the left, so that means this is negative 5. Negative 5. And this one, 1, 2, 3, 4, 5, because we are talking about opposites, so the opposite of negative 5 is positive 5. Both are equal distance. They are the same distance from 0. And doesn't that sound like absolute value? Well, let's see. Absolute value is the distance from 0 on the number line. Gee whiz. Sounding a little familiar. Let's go down here to the bottom. It says find the absolute value of the average low temperature in February. So it gives us the information. We're going to complete the chart, and then we're going to graph the temperatures on our vertical number line. Okay? So we've got the month, January, February, March, April. Average low temperature, negative 10, negative 8.5, negative 2.6, and 16. I can guarantee you that these temperatures are not in Tucson, Arizona. They're not pretty much probably anywhere in Arizona. You guys have never seen temperatures like this. So, what is the opposite of the February temperature? Well, we have negative 8.5, and since the opposite has to be a positive, and it has to be the same exact distance from 0, then it would have to be the same exact number, just positive. 8.5. Absolute value of February temperature. We did absolute values. We know that absolute value is always, always, always what? Yes, positive. Thank you for those of you that answered. So absolute value of the February temperature is going to be 8.5 because it has to be a positive number. Now, write February's temperature as a fraction. Ooh, there we go now. February's temperature was negative 8.5. So, a fraction, negative 8, because that's a whole number, and then we have 0.5, which is really 5/10, right? Which we can reduce to being 1/2, 8 1/2. And then the last one says, what's the absolute value of the March temperature? Well, again, we have another negative temperature, negative 2.6. So the absolute value of March temperature is, thank you very much, 2.6. Now, we're going to graph the temperature. We're going to graph all of these temperatures on this number line. That means put a dot on the number line. Not under it, not over it, not next to it, but on the line. Where do we put the dot? Yes, on the line. So let's go. Negative 10. Well, we know that 0 is here. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this is going to be negative 10, and we put a dot right there. Ta-da! We graphed it. It's not that difficult. February is negative 8.5. So we have to go negative 1, 2, 3, 4, 5, 6, 7, 8. But 0.5 is half. So we have to go down halfway between, and this is negative 8.5. Are you still with me? Good. Negative 2.6. Okay, now we're not going to be exact here because I am not dealing with trying to figure out 6/10 on this little teeny tiny space. So, I'm going to go down negative 1, negative 2, and 2.6 is about a half, so I'm just going to put it right about there. Negative 2.6, especially since I have this marker that's got a big fat end on it. I can't make little tiny parts. And then the last one, 16. Now that's a positive, so we have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Guess what? It's right here, 16. Who would have thunk it? Okay? That's all you have to do. When we say to graph something on a number line, for 6th grade so far, that's all you've got. We're just putting points on the line for right now. Got it? Let me slide up here. The very bottom says rational numbers in the real world. How about football? We use yards, right? We also look at sea level. If something's above or below sea level, we've got positive and negative. We already looked at this, but we'll put it on here. Temperatures. Those, positive, negative. Right? Something that shouldn't be negative, but hey, it happens. Bank accounts, that's right, sometimes. Okay? And it's not necessarily that you have a negative number of money, it's that when you subtract money from your account, it's a negative, and when you add money to your account, it's positive. Okay? And I don't know how many of you actually play. I know I don't, so I didn't know this, but golf scores are also rational numbers in the real world. So those are all examples of how we use rational numbers in the real world. You have to understand positive and negative, whole numbers, and positive and negative, fractions and decimals. Okay? That's the real world. Now, flip it over. Whoop. So, we've got, on which number line below does point X represent the opposite of 54? So, we're looking at 54. Well, I guess I shouldn't have colored that in. That's too dark. So let's circle it. 54. What is the opposite of 54? Yes. Negative 54. So we want to find which one of these has a dot at negative 54 with X on it. Let's see. Negative 54. Right there. Look at that. How easy. They gave it to us right away. Because that's a positive 54. And that's a negative 52. And that's a positive 45. So none of those. A. Going to try to trick you. What is the absolute value of negative 14.58? A, B, C, D. Remember, we are not changing the decimal. An absolute value is always, yes. So, if it's always positive, it can't be C. Boom, done. And if we're not moving that decimal point, it can't be that one or that one. It must be right there. 14.58, 14 and 58 100ths. And number 3, which number could be the absolute value of another number? Okay, this sounds very familiar. I believe on our absolute value note in our guided practice, it actually asked that. So, absolute value is never what? Ha, I gotcha. Because I always say always and have you say positive. So be careful. It is never negative. So, that's not it. That's not it. That's not it. It must be B. Too easy. Now, do your math practice and let's get done with this section. Bye-bye. Return to me with joy and honor.